So lesson 2.3, it's just more stuff about parallel lines, but we're going to throw in some triangles now. So thinking about this, if I give you a triangle, any triangle, it could be, a nice classic looking triangle. It could be a big old fat triangle. It could be a real skinny triangle, whatever. It doesn't matter. If I give you a triangle and you know two of those angle measures. So for example, maybe this one down here is 45 and this one down here is 75. Can we find this angle? Can we find that third one? All right, so given any two angle measures in your triangle, can you find the measure of a third? Anyone want to take a guess?
Yeah, I think you can.
Yes.
All right, he says yes, and I completely agree. Does anyone disagree? Does anyone think, how the heck are we supposed to do that? We are missing too much information. All right, well, we have another theorem, right? Another theorem talking about this one. This is a very, so I think I said that we use substitution and transitivity all the time, but we might be using this one. This might be one of our more widely used theorems. And this one is called the triangle angle sum theorem. This one's kind of cool. It says the sum, remember sum just means add them together. You add them all together. The sum of the measures of all the angles of a triangle is 180 degrees. All right, so measure of angle A, measure of angle B, and the measure of angle C, right? They will always add up to be 180 degrees, no matter what the triangle looks like. I shouldn't have erased the things that I had on here. So going back to this one, right, we could figure this out, right? If I take 45 and I add it with 75 and I add it with X, that equals 180 degrees. So that's just an algebra problem that, we can solve. We know how to do these. We've been doing these since probably 8th grade, if not before, maybe 7th grade. So in either situation, you're going to get X equals 60 degrees. So we can always find that third angle as long as we have the other two. All right. Now, this is such a bold statement here. Why don't we prove it? This is going to be the only proof that we do today, but this is a fun little proof. Prove the triangle angle sum theorem. All right, so we are given a triangle A, B, C. That's all they give us. All right, the only thing that we have is some triangle. All right, and it's like, how the heck do we prove something like this? A lot of these theorems, they have these really like creative proofs, and you really gotta appreciate some of these things they do. So this is triangle ABC. So we got an A, a B, and a C. And just like looking at that, it's like, how the heck do we prove that all of these angles add up to 180 degrees? Well, let me show you, because we definitely have to get a little creative on this one. And what we're going to do is we're going to use parallel lines to help us. So I'm going to draw two lines. All right, so there are my two lines. Now, remember we had that bonus theorem from yesterday that said I can draw a line through a point off of line AB such that it's parallel. So I'm going to draw this line M, right? M is going to go through point C such that it is parallel to line N. All right, so these are called auxiliary lines. I just kind of pulled them from thin air and I put them where I needed to because I think this is going to be beneficial. I'm going to label all of these angles now: angle 1, angle 2, and angle 3. All right, so what I can do is I can use the idea of alternate interior angles. All right, so I'm gonna add two more angles in here. I'm gonna add an angle 4 right here and an angle 5 right here. So if we had to do our T-chart, our statements, and our reasons, I'm gonna say, so like step 1 was we just have triangle ABC. That was given. All right, I'm going to say step 1. I'm going to say angle 1, well, that's congruent to angle 4. All right, and we know that because we have parallel lines M and N, so I guess this is really step 2. All right, so I'm going to say 1 is congruent to 4 by alternate interior angles. All right, and then I'm also going to say the same thing about 2 and 5. Angle 2, that's also congruent to angle 5. All right, because those are, again, 2 and 5 are alternate interior angles. Remember, the inside of the parallel lines, but they are on opposite sides of the transversal. And the transversal, in this case, is segment CB. The other transversal is segment AC. All right, so now here's what I'm going to say. Well, if you look at angles 4, 3, and 5, angle 4 plus angle 3 plus angle 5, well, all 3 of those equal 180 degrees. All right, how can I say that?
Because they're supplementary.
Yeah, they're just supplementary, right? Remember, supplementary is just 2 or more angles that add up to 180 degrees. So I'm just going to put supplementary angles. Supplementary angles. And now what I can do is I'm going to swap out angle 1 with 4. So step 4. I'm going to say, well, angle 1 is congruent to angle 4, so I got angle 1 plus, well, angle 3 is not going anywhere. And then 5 is congruent to 2, so I'm going to say plus angle 2. That also equals 180 degrees. So step 4, that was just 2 substitutions. And there we have it. Angle 1 plus angle 2 plus angle 3 equaled 180 degrees. That was the triangle sum theorem. So we used that theorem from yesterday that said I can draw any line through a point off of AB such that it's parallel. And then we used alternate interior angles twice to show that angle 1 plus 2 plus 3 equals 180. I forgot to draw the angle measures in here. Angle 1, angle 2, and angle 3. Those equal 180 degrees. And there we have it. That is the triangle sum theorem. So now you guys are more than welcome to use the idea of the triangle sum theorem in any proofs that you do, or just in any word problems or problems. They want us to find the missing angles, x and y. So I'll do x and then I'll let one of you guys do y. So if we have this triangle right here, all right, we know 32 plus 78 plus x, that equals 180 degrees by the triangle sum theorem. 32 plus 78, I don't know if that's 80, that's 110. 110 plus x equals 180. Therefore, x has to equal 70 degrees. All right, now, would anyone care to take a stab at y? There's an easy way and a hard way.
I guess I can do it.
All right, what are you thinking?
I'm thinking you add 32 plus 57 plus y, and that equals 180.
So we have to be careful because if I look at this triangle, we don't necessarily know that angle. But that's okay. We can get around that because look at the red triangle. Right? We have 57. So I'm going to do this all in red here. So we have 57 plus, well, oh, I already erased it. What was x again? Did anyone remember? Was it 70?
70.
1.
So x was 70. All right, so
70.
I'm just going to write that over here. X equals 70. So 57 plus 70 plus 32 plus that missing angle right here that's in yellow, that equals 180 degrees, right? Because these two we can kind of combine to be one big angle of the triangle. So we could figure out what that one is. So we have 180, and then we can just subtract all those numbers. So 57, 70, and 32. And then what that gives us is a 21. All right, so what we can do now is we know that this is a 21, and then we can go back to this green triangle now. And we know 57 plus 21 plus y equals 180 degrees. Therefore, y has to equal 180 minus 21 minus 57, which gives us 102. All right, so that was the hard way. All right, does anyone see an easier way to do this problem?
Yeah.
Yeah, what are you thinking?
So because 78 degrees and y, because they are supplementary,
Yep.
you can do 180 minus 78, and then you can find out what y is.
Exactly. Right, so just because we have all this extra information does not mean we need to use it, right? So we could literally have just done that and we could have figured out, oh, that's just 102. Right, but so with that being said, there's always multiple ways of solving problems, right? That the way we just did obviously would be the easier way. However, what we did here, this is completely fine. This is not wrong in any way, shape, or form, right? We still got the same number, y equals 102. It just took a little bit longer, right? So see if you can find those shortcuts. That's definitely going to help us out in the long run. Like on this one, we could figure out what x is relatively quickly, right? Sometimes it's a good idea if you have multiple colors, highlight the different colors, draw each triangle a different color, that sort of thing. So 35 plus 96 plus x, that's going to equal 180. Right, there's no getting around that one. We're going to definitely have to use the triangle sum theorem on this problem, which is fine. It's just an algebra problem. So if we could combine our like terms and say x plus 180, or if you wanted to, you can just subtract 35 and subtract 96, and then you're going to get x equals 49. Right? So it's never a bad idea to write in what you know. All right. So now we have this triangle. I see two ways right off the bat of how to do this problem. So any volunteers? Anyone want to try to make an equation for this one? So we can either use the blue triangle or we can use the whole big purple triangle. Which I think using the purple triangle might be a little bit easier, but it doesn't matter.
I was going to suggest doing it the same thing we kind of did last time with the 96 degrees.
Okay.
And it's supplementary with the other angle.
Okay, so what is this angle measure then right here?
180 minus 96, so
Okay.
84.
84. All right. Yeah. So now we have that blue triangle, that skinny triangle right here. We had an 84. We had a 77, and this one was our y. So we could do that. So using that idea, y equals 180 minus 84 minus 77. And then whatever that ends up being, if anyone has a calculator, or if anyone is a human calculator, go ahead and do that.
19 degrees.
We're going to get 19 degrees. All right. Another way you might have saw that or thought how to do this problem is if you look at the purple triangle, right, we could have come up with an expression for this angle. We could have just called that 35 plus y, right? It's just y degrees more than 35. And then we could have had our 77 and our 49. And we could have set it up that way. And that would have gotten us the answer. We could have just done 35 plus y plus 77 plus 49. That would equal 180 degrees. And again, that still would have gotten us to our y equals 19. So there's always multiple ways of doing these things. So just because you do it one way, but my answer key or something does it another way, or somebody you're working with does it another way, does not mean yours is wrong. Right? So there's always multiple ways of doing these things. All right. Ooh, so this one we're going to have to use a little bit of geometry theorems in here. So x right off the bat. I'll give you x. That's just 180 minus 57 minus 59. That gives us 64. All right. But what do we do from here? How could we figure out y in this problem?
Since x is a vertical angle with the angle on the other triangle, you can find out what that is. And then you can do the same thing that you did on the other triangle.
Exactly. We have vertical angles. Good. So vertical angles are super important. And I think that's one of the easier things to see. Vertical angles, that's just free information. Right? So if you want to draw that triangle over here, doesn't have to be perfect, but we know this is 64. And we know this is y, and we got a 42 up here. Right? And there we go. Right, so sometimes we will have to find another variable for, right? Sometimes, so like finding y really depends on finding x first. So just keep that in mind. Sometimes we'll have to do that. So in this case, we got y equals 74. Right, there's no way we could have found y first without finding x. All right. Oh, there's another one. I forgot about this one. Triangle exterior angle theorem. All right, so the measure of each exterior angle in a triangle equals the sum of the measures of its two. So here's a keyword: remote interior angles. All right, so what that means, all right, that sounds fancy, but here's all it means. If I have an angle on the outside of a triangle, I could draw any triangle and extend one of these sides. All right, so angle 1 here, we call this an exterior angle because it's literally, it's on the outside of the triangle. So that's why it's an exterior. All right. The measure of angle 1, that's just equal to the two angles that do not touch, angle 1, that is not adjacent to angle 1. All right, that's really all that one's saying. And basically, we know that this angle right here is 180 minus angle 1, right? Because those two things have to be supplementary, right? I could have called that angle 4, and I know angle 1 plus angle 4 have to equal 180 degrees. So you could say angle 1 plus angle 4 equals 180 degrees. Well, we also know that angle 4 plus angle 3 plus angle 2, those also equal 180 degrees because those are the interior angles in a triangle. All right, so what we can do is we can take these two things, set them equal to each other. We can say, oh, angle 1 plus angle 4, that's just the same thing as angle 4 plus angle 3 plus angle 2. All right, and then the subtraction property of equality, get rid of those angle 4s, and all we're left with is angle 1 equals angle 3 plus angle 2, right, which is what we have right here. I just wrote them in a different order, but that's all that one says. Nothing too groundbreaking, but if you do know that, you don't need to necessarily know this theorem, because you can always figure out this angle if you have 2 and 3, but it'll just save you a little bit of time if you do know that. So this right here, this is kind of like a sketch of a proof. We didn't really do a T-chart. We just kind of talked our way through it, did a little bit of algebra to show that. So, looking at this one, find the missing angle measure in the proof. All right, so maybe we didn't know that exterior angle theorem. What we would have to do is we would have to figure out, angle X first, and then just do 180 degrees minus angle X. But now that we have this exterior angle theorem, all we have to do is just add those two numbers together. We have angle 1 equals 45 degrees plus 75. These are the remote interior angles. And what that means is they just don't touch angle 1. They don't share a side with angle 1. All right. So angle 1, that's just equal to 45 plus 75. That's 120 degrees. All right. So now this one's a little bit different. All right. Now they give us an exterior angle. And then they give us two remote interior angles. All right. So somebody give me a setup for this equation. I feel like I'm talking a lot. Somebody help me out.
$51 plus angle 2 equals 109 degrees.
Perfect. 52 plus angle 2, 51 plus angle 2 equals 109. So subtract that 51 from both sides. So since we're in honors geometry, I'm probably gonna skip, writing this step each time. I feel like you guys can probably handle that. So what does that give us? 50, I think that gives us 58. And there we have it. Angle 2 is 58 degrees. All right, so I think this is the last one I have for you. All right, so we're building this funky looking, shelf. I guess we're gonna put all of our, C collection stuff on here. Each shelf is parallel. So remember, a shelf is like the horizontal part that you actually put stuff on. Each shelf is parallel to the base. All right, so if we look at all of these flat lines, these are all parallel. All right, and we're gonna have to use that idea. All right, they want us to find angles 1, 2, and 3. They don't care about 4 and 5, they just want to do 1, 2, and 3. All right, so it's just that same picture just blown up a little bit. Where the heck do we even start on something like this? Let's go ahead and draw these parallel lines in here. And then I guess I can do this too. All right, any ideas? Because there's a lot going on here. Any suggestions?
You could start off with the bottom triangle. So you could get angle 5.
Okay, yeah, definitely. What is angle 5?
Well, it's 45 plus 55 plus angle 5 equals 180.
All right.
So angle 5 is 90.
Angle, careful, careful.
Oh, sorry, it's
But
80.
it's 80. Yeah, good call. All right, so 5 is 80. All right, so we could throw that up here. We say angle 5, that equals, whoa, angle 5 equals 80 degrees. All right, I agree with that. Now what? What if we did this? I'll give you a hint. What if I looked at this right here? Can somebody come up with an expression for what I just highlighted? So angle 1 and 55 together. How could I say that as an algebraic expression? If I wanted to know the measure of that entire thing, yeah, Lucas.
I have a question. If
Okay.
we add 55 degrees plus angle 1 and angle 3, would that just equal a right angle or 90
So
degrees?
we don't know for sure if this equals 90. It kind of looks like it. Yeah, if you look at this angle right here, it looks like it might be 90 degrees, but can we say that for certain?
No.
Well, actually, you're right. We can. If we look at this yellow triangle here, yeah, we could say that because look, we got a 45 degree here and a 45 degree here. 45 plus 45 is 90. So this big old angle down here is also 90 degrees. So you could say that. So that might be beneficial. But what if we just look at angle 1 and angle 55? Right? Is that equal to anything? Using our property of parallel lines, you guys see what that might be equal to?
Is it equal to 75?
It is equal to 75. How do we know that? What property said that it's equal to 75?
Corresponding.
Yeah, these are corresponding. Corresponding angles. Yeah. So now we have an expression. So those corresponding angles help us out. All right, so we know 55 plus angle 1 equals 75. So from there, we can say angle 1 equals, what is that, 20? All right, so now actually, now we can do what Lucas was saying, right? If I go back and I look at, I'm not gonna use yellow because it's too bright. I'm gonna make this a purple triangle. If I go back and look at this, all right, I'm gonna draw this over here. We had a 45, we had another 45, and then we had that angle down there. That was angle, this was 55 plus angle 1 plus angle 3. But we know 55 plus angle 1 was 75 degrees. So we can change that, right? We knew 55 plus angle 1 plus angle 3. Right? We knew that was equal to 90 degrees. But we know what 55 and 1 together are. That was just 75. So we have 75 plus angle 3. That had to equal 90 degrees. Right, or I guess if we want to stick to that triangle sum theorem, we could do plus 45 plus 45 again, and that equals 180 degrees. Right. All right, so now we have enough information to figure out angle 3. So I'm going to take those 45s and I'm going to subtract them over, and that's why I have 75 plus 3 is 90. So Lucas, you want to finish this one off? What do we got for angle 3?
Angle 3 equals 55 minus, what was it, 20?
Careful. So angle 1 ended up being 20 degrees. So
Yeah.
let's use this problem right here. So we were able to add those together, and that was this part here. But now what we're doing is we are looking at all 3 of those together. All right, so angle 3, if you look over on the right of the screen, we have 75 plus angle 3 equals 90. Therefore, angle 3 must equal
15.
15. And there we have it. I think they only want us to find 1, 2, and 3. We found 5. I guess we could find 4 if we really wanted to. All right, so looking at, man, I'm really running out of colors here. We're going to do a dotted pink line. All right. Looking at that one here, we know angle 3 was 15. So we could say, I guess, going down here, we say angle 3 plus angle 4 plus 45. Angle 3 plus angle 4 plus 45 degrees equals 180. All right. We already know what angle 3 was. We found out that was just 15. So we have 15 plus angle 4 plus 45. That equals 180. Therefore, subtract everything over, and we're going to get angle 4 equals, let's see, 15 plus 45 makes 60. 180 minus 60 gives us 120. All right, so they only asked us to find 1, 2, and 3, but we found all 4 of them, or all 5 angles. We found angles 1 through 5 on that picture.